Hello everyone, welcome to my channel. In this lecture, we will discuss about the adsorption of lead ion from wastewater with the help of commercial activated carbon. So this is a paper which is related to the dynamic simulation of lead metal adsorption from water with the help of activated carbon in a page bed column. So we will use the S1 adsorption simulator to remove the lead ion from the aqueous solution with the help of commercial activated carbon. So here they have used in this paper the other used two adsorbent. One adsorbent is tile derived activated carbon and the second one is commercial activated carbon. So I will use commercial activated carbon in this simulation. Okay, and you know that lead is a heavy metal ion and it is very harmful for human, plant, and human being. So its removal is very necessary. Now we will go to the S1 adsorption. We will add our feed and product specification. So go to the S1. We will open the S1 adsorption. So in the S1 adsorption, we will give the feed and product information. Go to the component, configure, use, edit using S1 property. So here we will go to the S1 plus and we will add our component which are lead nitrate. So lead nitrate is a salt and it consists of lead ion. When we dissolve lead nitrate salt in the distilled water, then it will give us the lead ion, and that lead ion will be adsorbed with the help of activated carbon. So first of all, in lab we make the solution of lead ion. We make 1000, 2000, etc. ppm of solution, and after that we start our adsorption experiment. So go to the component and add the component lead and nitrate. Now click on next. Select the property method. I am using the electrolyte in RTL. So there is no need to add water because it will be calculated by this NRTL package. Now go to click on next, click on OK, go to the S1 adsorption, click on OK, and again come to the S1 plus. It is calculated, click on yes, go to S1 adsorption again, double click on default and click on this arrow to add the component. So we have added our component from S1 plus to the S1 adsorption. Now click on liquid column. This is liquid bed, liquid adsorption column, the liquid feed, and the liquid product. This is feed and this is the product information. Now connect the stream with bed. So this is the liquid material connection. Add feed to the adsorption column and add product to the adsorption column. Specify the feed, double click on the feed, click on specification. So here we will give the specification for feed. So they have used various molar flow rate of feed like this one, etc. And there are the concentration of lead ion, 500 ppm, 1000, 2000, 3000 ppm. And the internal diameter is this one, the interparticle voidage, the feed temperature is 25 and pressure is 3 bar. So 25 degree, 25 degree, 25 degree and 3 bar pressure. The molar flow rate of the feed is this is the volumetric flow rate of the feed. So the volumetric flow rate of the feed is there are various flow rate, but I am using this one. Suppose this one, like this one, volumetric flow rate 4.94 multiplied by 10 raised to power minus 4 meter cube per second. 4.94 4.94 multiplied by 10 raised to power minus 4 meter cube per second. 4.94. Okay. Now this is the nitrate concentration. So the nitrate concentration is supposed very small. So I will assume it is 0. If you want permission, you can add it, but I am just leaving it to 0. The lead concentration is in ppm. So here you can use this one, the lead concentration. Okay, this one. This is the where this is B is for the commercial activated carbon, and this is for the tire derived activated carbon. Okay. So I will use this one. This is for commercial activated carbon, and this is the concentration of the metal ion solution. So the concentration of metal solution, concentration of lead solution. So 500 ppm, 1000, 2000, 3000 ppm. Okay, this is the time. This is the breakthrough curve, and the temperature and pressure of the fluid is this one. This is the molar, the volumetric flow rate, and the bed height is 0.4 meter. Bed height is 0.4 meter, and the concentration here. So I will use this one, 3000 ppm. So 3000 ppm, we will convert the ppm to molarity. You can use the online calculator to convert it. So I will just, it will about 0.014, 0.014, about 0.014. Okay. Now close this one, double click on product, click on specification. So there is no concentration of lead and nitrate in the product stream. It is okay because at the beginning there will be no lead and there will be no nitrate ion in the product concentration in the product stream. Double click on bed. So here, this is there are one layer of the activated carbon, vertical position. Click on this one, and the general, the discretization method is used as one. There are 20 number of node. So here you can see the discretization method is UDS1, 20 number of node, 20 number of node, and the material is convection with estimated dispersion. Material with estimated dispersion. And the pressure drop is non, the velocity is constant. Here you can see pressure drop is non, velocity is constant, film assumption is solid, and the kinetic model assumption is linear lump resistance. Linear lump resistance solid, and the form of mass transfer coefficient is constant. The isotherm is here you can see. The isotherm is Langmuir 1 and the Langmuir 1, and the energy balance is isothermal. So Langmuir 1, this is not Langmuir 1. Energy balance is isothermal. Okay. Now the bed height has, you can see, the bed height is 0.4, and this is the solution. This is the concentration of lead ion which are entering to the adsorption column. So the height is 0.4 meter, and the bed diameter is, you can also check here, the bed height is 0.4 meter. Okay. The diameter of the bed is the particle size here. This is the particle size of activated carbon, commercial activated carbon, 0.02 meter. So 0.02 meter. The particle adsorbent particle radius 0.02 millimeter. 0.02 millimeter. 0.02 millimeter particle radius. So it can be 0.01 millimeter or 0.02 millimeter. I am assuming this one 0.02 millimeter. The interparticle voidage is 0.4, and the internal diameter of the adsorption column is, so here you can see, this is the diameter of the adsorbent layer, and the interparticle voidage are 0.025 and 0.4 respectively. So the diameter is this one, 0.025, 0.025, 0.025. This is the diameter of the adsorption column. Or you can say this is the internal diameter of adsorbent layer. The interparticle voltage is this one. Okay. The density of the commercial activated carbon, so it is about 2000 or 2100. So here you can see it can be the density for activated carbon 2050 kilogram per cubic meter. Density for the commercial activated carbon is 2050 20 2050. So 2050 kilogram per cubic meter. The constant of mass transfer coefficient. So here the mass transfer coefficient, this is the flow rate. So the flow rate of the fluid is this one. The mass transfer coefficient will be this. So this is calculated. This can be calculated from various equation, from the Sherwood number and various relation like this one. From this is the Reynolds number. This is the, here you can see this is the Schmidt number. So this is the diffusivity of A and B, the diffusivity of lead ion in the water, etc. So the diffusivity, this is the Schmidt number. This is the viscosity of the fluid, the diameter of the particle diameter, etc. This is the viscosity, superficial velocity. This is the mass transfer coefficient, Sherwood number, Reynolds number, etc. So from this relation you can find the mass transfer coefficient. So for this relation it is 0.3. You can also calculate the isothermal parameter from various equation. So here the mass transfer coefficient is this one in 1/second unit. So 0.342, 0.342, 0.342 for lead ion. I'm just leaving this one for nitrate. For nitrate, I'm leaving this one. Assume one. I'm assuming one for nitrate. If you information, you have data, you can enter it for nitrate. And also for lead ion, the isothermal parameter. So isothermal parameter, I'm just using these parameter. You can obtain the isothermal parameter from various equation, but here I'm using these two. Then mirror isothermal parameter, like this one, the maximum uptake of the activated carbon and the Langmuir constant. You can obtain the isothermal parameter from correlation or various equation. First, I'm just using these two. So at 42.5, 42.5, 42.5 and 0.008. And for nitrate, I'm giving 1. The direction is 0.008, 42.5. Okay. Now click on initial, close this one, click on initialize, click on yes, close this one, change it from dynamic to initialization, click on run is completed, click on new form. So I'm breakthrough curve, I'm plotting breakthrough curve for lead ion. So drag and drop this one, double click on product stream, click on the results. This is the lead, the concentration of lead ion in the product stream. Here you can see this nitrate, lead, this is a mole fraction. So let drag and drop this one and change the time from 0 to 1300 seconds. Suppose grid interval is 50, time window is 1300. Click on apply, click on OK. Now go to dynamic and maximize this one, click on run. So it will take some time. So I will stop this one. I will click on this one, this run option. So my simulation will stop at 1300 because if I'm not selecting that, my simulation will continuously, it will run continuously. So I will pause my simulation at 1300, click on OK, again run simulation. So it will start. So here you can see it is equilibrium. This is equilibrium. This point. Click on OK. Minimize this one. So here you can see this is the equilibrium. So I will change the time axis from 13 to suppose 400. Apply, and this is suppose 20. And OK. So here you can see the concentration of the molarity of lead in the period was 0.014. It was 0.014. So the breakthrough point. So the breakthrough point will occur when this concentration reach to when the outlet concentration. This is for outlet concentration. Here we have plot this one for outlet for the product stream. The concentration of lead in the product stream, which are coming out from the adsorption column. So here you can see this is the fluid concentration. So here you can see this is the fluid concentration again. So this is the breakthrough. This is the saturation point. After saturation, all of the lead ion which are entering to the column will leaving the adsorption column. So here after 300 seconds, all the lead ion, the concentration of lead ion, the ion of lead ions which are entering to the column will leaving the adsorption column after 300 seconds, and it is called the saturation point. Or you can, and this is the breakthrough point. The breakthrough point is when the outlet concentration is 5% of this one. 5% of 0.014. When the outlet concentration reach to 5% of this one, so suppose this is about the 5% of this one. So it is suppose it is at about 74 second. 74 second is the breakthrough point. So breakthrough will occur at 74 second or 70 second at this position. 70 second, and the 95% of this one is about so here 307 seconds. So 307, after 307 second is the saturation time for this bed. This bed will reach to saturation after 307 second. After 307 second, the bed will reach to saturation, and this is saturation time 307 second. Here you can see 309 or 300 300 307. So after 307 or 310 seconds, the bed will reach to saturation, and this will be the saturation time for the adsorption process. So now I'll plot some other graph like the adsorbent load versus time. So click on this one. Adsorbent uptake. Because uptake and loading are same, adsorbent uptake versus time. Click on OK. Click on this one. Change this one from 0 to 1300. 1300. Interval is 50. Click on Apply. Click on OK. Double click on the column. Click on this one. Go to results. Go to solid loading. Solid loading. Solid loading. So the lid at the beginning. The point 1 is the beginning, the bottom of the adsorption column. The lead ion, what will be the concentration of lead ion at the bottom of the, what will be the behavior of the concentration of lead ion at the bottom of the adsorption column after various time, and what will be what will be the behavior of the lead ion in the middle of the column after various time, and what will be the behavior of lead ion in the column at the top of the absorption column with the passage of time. So 10 position number 10 is this one. This is the middle of the column, and this is the top. 19 is the top. So here you can see this is the lead ion the uptake reached at the beginning very fast. Here you can see the situation will occur after the situation will occur at 50 second, about 60 or 70 second, about 60 or 70 second. The situation of lead will occur in the bottom section of the absorption column. In the middle section of the absorption column, the situation of lead will occur in the middle section of the absorption column after here you can see after 200 second, and after 300 second the saturation of lead ion in the upper section of the column will occur after 300 second. Here you can see this is the various portion, the bottom, this is the middle section of the column, this is the top section of the absorption column. I will also plot some other graphs like click on this one, click on profile, uh, adsorbent uptake, uptake, adsorbent uptake, height, height of the column versus time and time. So I'm click on OK. Okay. Now right click on this one, click on profile variable and click on find variable. Click on find. Okay. Now this is the plot will be, this is the y-axis, this is the x-axis. So on the x-axis the height of the adsorption will be on the x-axis. So the height, this is the height. As you can see, this is the 0.4 is the height, the total height of the column. So drag and drop this one. Okay, this is the height of the adsorption curve. It is in meter. Okay, this will be on the x-axis, on the this graph on the x-axis. Now on the y-axis I am using some other the loading adsorbent, the adsorbent uptake, the solid loading like this one, solid loading. You can also search here, solid loading. Yeah, or adsorbent uptake. Adsorbent uptake. This is the commercial activated carbon uptake. So we will remove 18. We will use star in place of 18. It means that the uptake will be for whole column. Plot this is on the y-axis. We will also plot some other. Okay, this one. Now go to the closest one. Go to time setting. Okay, click on specify time. So after 100 second, 200 second, 300 second, 400 second, and 500 second. Click on OK. Is this one? So here you can see as we go from bottom to the top, the adsorbent uptake decreases because more and more lead ion will be attached to the activated carbon as we go from bottom to the top of the adsorption column. But after a certain time saturation will occur inside the bed, so there will be no uptake. Here you can see this is constant line. So after 500 seconds or after 400 seconds there will be saturation inside the adsorption column. So we will start desorption after 300. After 300 seconds, here you can see after 300 seconds it is almost saturated. There is no uptake inside the desorption column. So this is the that how the uptake take place inside the adsorption column. Thank you very much for your attention. If you are new to the channel, please like and subscribe.